We're going to talk today about this new concept called a flipped classroom. And I'm going to use this new software called Doceri, where we will do the lecture and notes on the video, and then you can take notes on this and come to class and we'll do our regular homework is done in class. We can do that together, and those people that can work independently. Those people that need to get more help can get more help. So our lesson today is going to be on what's called Prime Factorization. And how prime factorization works is that you have to first of all remember your prime numbers. Now, hopefully everybody remembers their prime numbers. 1, 2, 3, 5, 7, not 9, 11, 13, and 17, on and on and on. Remember, a prime number is a number that's only divisible by itself and the number 1. So the concept that we're going to use is called factor trees. Factor trees. And I think they're called that because you start at the top and you work your way down until you have a tree of numbers. So we're going to look at factor trees. The first number we're going to factor is 12. And I'm going to switch pens. And 12 is divisible by 2 and 6. I always like to start with 2 if I can. 2 and 6, and then 6 is 2 times 3. And once we get it to a prime number, then I'll circle those. So we have 1, 2, 2, 2, so we have 2 to the second power times 3, and there's only one 3, so I don't really need to put the 1. It's implied, so 12 factored is 2 times 3. 2 squared times 3. Let's look at another one. Let's look at 16. 16, let's start with 2 again. 2 times 8. And then 8 is 2 times 4, and then 4 is 2 times 2, so I have 1, 2, 3, 4, so I have 4 2's, and that equals 16. And that's the prime factorization. Let's look at a different number. Let's look at 18. 18. 18, again, I'm going to start with 2 because I can. 2 times 9. Is 18, and 9 is 3 times 3. So now I have 1, 2, 1, 2, and I have 1, 2, 3's. So I have 3's, I have 2 of those, and this equals 18. Who's ready to do a bigger number? How about 125? Now I can't divide 125 by 2 because you know I always like to start with 2. But I can start with 5 because I know that 125 is divisible by 5. And if I look, 5 times 25 is 125. And 5 is a prime number. And 5 times 5 is 25. So I have 1, 2, 3 5's. So 5 cubed, or 5 to the third, is equal to 125. How about 126? Oh, 126. So different than 125. There are no 5's in 126, but I have a 2. So 2 times 63, and 63 is 3 times 21. And 21 is 3 times 7. Now you might have said, hey, Mrs. Spencer, isn't 63 also, what also is that? 9 times 7? Well, sure it is. So I can also do that, and I'm going to end up with the same thing, which is 1, 2, 1, 2, and 2 3s, 1, 2, 2 3s, and 1 7. So it doesn't matter which way you go on your tree, as long as you go all the way down to the prime number, you will still get the same answer. And in this case, it's 2 times 3 squared times 7 is 126. And now we're going to do one more. We're going to do a really big number, 9,520. Again, I'm going to start with my 2. So 2 times 4,760. And now that also is divisible by 2, which takes me to 2,380 divisible by 2. 2 times 1,190 divisible by, 190, let's do 5. So if I do it by 5, that's 238 times 5. I'm going to start up here. 238 is 2 times 119, and 119 is 7 times 17. And if you want to look at how you can remember that 119 is still divisible by other numbers, you can read on my blog about how there are some tricks to deciding if a number is divisible by 2 or 3 or 5, 7, 6, all of them. I go all the way up to 11 and beyond in some cases. So now we have 1, 2, 3, 4 2's, so 2 to the 4th, times 1 5, times 1 7, times 17, because 17 is prime, and we know that 2 to the 4th times 5 times 7 times 17 is equal to 9,520. Now you can see right here, when we got to this point, I could have taken 1,190 and I could have split that up 10 and 119, the same as here, but with a 5. So you can take different paths down your tree. And that is how we do prime, let me switch pens because I'm practicing, factorization. You take numbers and you go all the way down to the prime numbers. And there we have it.